Am I the only one here?
No, Cameron is here.
I'm not seeing any names.
Log out and log in again.
Now I see them. Good morning, Cameron.
Good morning.
Happy Thanksgiving.
Yeah, happy Thanksgiving to you too.
Good morning, Paige.
Good morning. How are we doing?
When are you going
Oh,
to Medford?
Me?
Yes. Aren't you gonna get the turkey from Costco?
So I'm already home. And so I've been home for a couple days. And so I'm in Bellingham, Washington right now. So
Oh, yeah.
yes. So we got that yesterday. Very exciting stuff.
Okay. And is it raining?
Is it raining?
Yes.
No,
Washington.
actually.
I thought that Washington
kinda-
is raining all the time. My daughter is in Seattle. She's wet all the time.
Yes, normally it is wet, but it's kind of funny. It hasn't been the past like week. And my dad was actually complaining about it because he owns a small hydroelectric facility. And so he might have to shut it down because there's no rain going through the hydro.
Oh, yes, yes. And he is selling electricity to the utility?
Yes, back to the county. So it's been doing pretty well, which is exciting.
Yeah.
Yeah.
How many he's working alone on this project?
Yes, he's an electrical engineer. And he kind of picked it up as a side project a couple years ago. And just this year he got it running. And so yeah.
Is he gonna offer you a job?
You know, that's what I'm thinking. Because electrical and renewable energy, it seems like that would do the job there. So
Yeah, it is booming.
yes.
Hello,
And you
Jose.
get to stay in Bellingham.
One more time. I missed that.
And you get to stay in Bellingham.
Yes, I do.
Morning,
Hello,
Professor.
Jose. How are you
Morning.
today?
Good. How are you?
Your turkey is ready?
Nah, not yet. I still gotta go hunt it.
Okay. We'll wait a few minutes for some people to show up.
Dr. Amar,
Yes, sir.
I'm really getting tired of that beach and palm trees behind you. Can you change that to something that makes me not want to be there so much?
Okay, we can do that later on, but right now I have to study how to change it, but let it be this way for a while. What do you want to see? The pyramids? Egyptian pyramids?
Oh, no. Luxor.
Luxor? That is far away.
What classes are you going to teach for OIT next quarter?
Wilsonville. This class and 335.
You're going to teach this one again?
Yeah. I'm still missing homework 4 from few students. Does anyone have any problem with homework 4?
I'm still working on it, but I think I figured it out.
Okay,
Hopefully I can finish it this afternoon.
very good.
I'm not as sharp as some of the young people, you know.
Sharp, or you don't have the observant eye to figure out the errors. That could be, but it needs training. That's it. But you wrote the program. That's good.
I suppose. Jose, are you home too?
Yeah.
And where is that?
It's in Vancouver.
Okay.
Oh, that is far away.
Yeah, it's very far.
How cold is it?
It's better than Klamath. It's not snowy.
Oh, really?
Well, it wasn't snowy, but yeah, way better.
How far from Portland are you?
About like, I'll say like 20 minutes, I think.
So it's a 6-hour drive home then.
Yeah, it's very far. But I have family in Woodburn, so that's what I did. I drove to Woodburn first, and then I came to Vancouver.
I see.
Yeah.
I think we should start now. Our last lab, lab 3, we have a few programs that we should run. How many? 3 programs. The first one is switch debouncer. In this switch debouncer, we had it under That was here, slide 11. We spoke about this switch debouncer, and we said that this one, if I have a spring in my switch, when the switch turns on and off, the spring may oscillate and causing false data. That's why I use this switch debouncer circuit. In this switch debouncer circuit, this is my push button. It passes through two cascaded D flip-flops, and I am comparing those two. Those two are compared through an exclusive OR. If they are matching, that is good. But if there is a discrepancy, one high and the other low, that is bad. So I need a stable operation. A stable operation means the output of first flip-flop is the same as the second flip-flop, and that should last for a certain period of time, maybe 10-20 milliseconds. After 20 milliseconds or 30 milliseconds, I would say, yes, I am having a stable input after passing all the expected discrepancies due to debouncing, and I can send that out of the third flip-flop. The third flip-flop should be energized after making sure that the flip-flop 1 and 2 have the same signal for a prescribed time. So now, with this exclusive OR, I am comparing the two signals. If the two signals are identical, this is exclusive OR. If they are not identical, I will get high. High means clear the counter. Counter is not counting anything. But if they are identical, I will get 0. When I have 0, the clock will increment the counter until I reach my terminal count. When I reach my terminal count, I am enabling the third flip-flop to send the output. This is the structure of my circuit, and here is how I select how many bits the counter should be. Number of bits is 2 to the power n. It depends on for how long do I need this to stay. If I say 10 milliseconds, I put here 10 milliseconds over f. F here, it is the frequency of your clock. So F is the frequency of my clock. P is my duration that I need. For example, this example is 10 milliseconds. 10 milliseconds. This is the program. And I believe most of you did it while we were in class, maybe 2 or 3 weeks ago. We had this program and we saw it running together, and I believe Vitaly showed us how. And I believe we needed to reduce the number of bits and make the clock slower, not to exceed the limits of the waveform generator. This is for this assignment. Any questions about it? Any questions? Okay. My second assignment, it is up-down counter with synchronous reset. This one, it is using generic parameter 16-bit. I can see it, it is a normal counter. Just we have here the generic 16-bit. So I'm sure you did it several times. Last one. I am using this up-down counter, the previous one, but here I am using my switches, external switches from the board, and I'm adding to it the bouncer input. So I'm using the input from the board itself, and in addition, after I take the input, I pass it through a debouncer to make sure it is correct. This will be a good one, and of course, it shouldn't be difficult. After you do the first one, you are gonna just, after you do the first and the second, the third is just combination of the second, which is the counter. In addition to it, I am using the bouncer switch. Okay. Any questions? Okay, I'll give you maybe 45 minutes to work, or 30 minutes because you did it before and you have the code to work on the first one. So please go ahead and start the first one, and we have 30 minutes for this task. Okay. I'll stop sharing. Any one of you may share the screen, may ask any questions, and the rest would answer. And I am just sideways. Hello, hello.
Hello, Professor.
You want to show me something? The bounce? Anybody want to show his debounce switch?
I'll show mine.
Okay,
Give me 1 second to pull it up here.
take your time.
Sorry, I'm just adjusting the test bench here. I realized I was making these times that the switch was on for much too short. So I'm just gonna make these a little longer. And I'm just trying to put them at random times so that they compile that, and then give me a second.
Could you go over the main program before you go to the test bench?
Yes. Yes. So what happens is we have two, when I instantiate this, I have the number that this is counting from, the 2 to the 5th, and then the terminal count. So that's how far the clock is going to go before it, and you can adjust that. And then I have the 3 parameters to switch in, which is the button press in.
You are showing the third program,
The debounce.
the debounce by itself.
Yes, the debounce by itself.
Okay, okay.
And then I have the debounce output. And so when I go and put that in our process, I have the 2 flip-flops here.
Yeah.
And then I have the XORed inputs or from the 2 flip-flops, which is here, this X. And if that's high, then the count goes to 0. Otherwise, it'll count every clock cycle. And if this count is the same, so B count is equal to terminal count, the output, the debounce circuit will be the same as Q12.
Yeah.
And I was trying to do this a different way than you had in your program. And I guess that's why it took me so long. Yeah, I just ended up using pretty much the same thing that you did. I can show you what I got for my, hold on, I go to the RTL.
Before you go on, how much time did you leave your debounce? I couldn't see there.
I have it on for 31 clocks, but you can make it longer or shorter than that. It's kind of hard to simulate it in the test bench because, well, here, I'll show you. I didn't know like what a real switch would look like. And so it's kind of like,
It says that 10 millisecond would be accurate enough.
yeah. Okay. One sec. Shoot. Did it ever go? Trying to look. It's kind of hard to see sometimes where it's 32 clock cycles out. So, yeah, see, here's the problem. I think it is because it's worked before, but sometimes when I change how much the switch in is on for, because I tried to make it like an actual switch where it's turning off and on. It doesn't go, and I don't know if that's what's wrong with that.
So when do we get the final output to go to 1?
I don't. At this time, it didn't do it, but in other times it's done it, and I just had it working.
Oh yeah. your switch should be on for 31 cycles, for 31 clock cycle before
Oh,
it
for
can
31.
respond.
Oh, okay. For it to work, okay.
Yeah,
Yeah, that would make sense,
you
I
need
guess.
to extend the last one.
Okay,
The
well,
last
I'll,
high extended. Make it 35 or 40.
okay, I can change that in the test bench.
Yeah.
So 325 times. Hold on. $875. Give it one more sec. Okay. Over here, we can compile that. Wave. Ah, there we go. Now the debounce out is going.
Yes,
after 31.
yes, that's correct. Now it's happening. Yes.
All right. And it doesn't, I think I just, when this is off. Yeah, just setting it for the, but it looks like, yeah, that's about 31 from here to here. Because this should be 875 nanoseconds from here to here.
Yeah.
So, okay, I guess that's working.
Okay,
Well, that's about it. I'll stop sharing.
great. Thank you. Hello, Chad.
Yes, Professor.
Do you have it working now?
I do, yes.
Okay, would you show us?
So I'm doing it on my desktop, and then my Zoom is on my my laptop. So
Okay,
yeah.
Vitali, you showed us before, correct?
Yes, Professor.
Okay. Jose?
I was working on it, but my laptop died. It's I'm trying to find my
So-
charger. I'll show
You
you.
need more time for it or what?
Yes, please.
Okay. Page. Hello, Page.
Yes, hello. I am just not compiling it, creating the waveform right now. I'm trying to do it on the waveform editor rather than test bench, so I'm hoping
Okay.
that's gonna work.
We'll give you 10 more minutes. And those who finish it, they may proceed to the second part.
Okay, I don't even think it'll take 10 minutes. It'll take like a minute, and then I'll see.
Whatever, for everybody, we'll give 10 minutes. Okay?
Okay.
Thank you.
So I ran my simulation and I keep on getting 0 as my output, and I'm not quite sure why.
Last time we
You-
saw that we had the pulse, the last pulse. You are inputting high, low, and the last high should last for longer than the clock terminal count.
Okay, I'll retry it. I tried to do that.
Paige, if you share your screen so I can see how long your clock cycle is, I can kind of explain it.
Okay, gotcha. Hold on, let me try and rerun this and see if it. Um, yeah, it's still not working. Okay. All right. All right. You see it?
All right, so yeah, click on your clock for me really quick. And then go to that C value. Okay, so it's occurring every 15 nanoseconds, which means it has a period of 30 nanoseconds. So
Right.
do you remember the formula? P equals 2N over F.
Right.
So what that's saying is P is the period that your switch has to be on in order for it to actually register an output. And so N is obviously dependent on how many bits in your counter that you have. And then F is the frequency of the clock. So what you're going to do is, how many bits are you running?
I think 16, but
So go back to your code and make it something like 4 or 8,
okay. Let's go 4.
and then change wherever else you have that dependent on.
Well, it's generic, right? So it shouldn't.
Oh, okay. You don't have it like listed anywhere else, so where it's like
I don't
counter
think so.
size. Okay, perfect. Sweet. So
Okay.
now if you're to do your formula, actually also go back to your clock. Oh yeah, after you process this actually.
Okay. I'm gonna. Oh,
Nice. Now make a new waveform.
Okay. Okay.
Move your clock to the top so just a little easier, just by dragging it.
Sorry, one more time.
Drag your clock to the top just so it's like easier to like see.
Gotcha. Yeah.
Perfect. All right, now click on the clock, like that count value. And do it, yeah, just keep it on every 10 nanoseconds.
Okay.
And then set your end time to like 1.5 microseconds. There you go.
All right.
Sorry, do that for the full clock one more time. Just like click the clock and do that again.
Sorry, one more time.
Just click on the
You
clock.
keep on cutting out, and I'm not quite sure why.
Sorry, just 1 second. Can you hear me a little bit better?
Yes.
Okay, sorry, I had, had a fan running in the back. Yeah, just click on the count value again up top,
Okay.
and then just hit OK. Basically, it'll extend it for that new duration. There you go. Sweet. So yeah, like I said, your button period, like the literal time length that you have it on, like pressing it down, needs to be equal to that value 2n over f. So I just use the same values. That's why I made you do that. So
Okay.
from 0, drag it out to like just past 320 nanoseconds
Okay.
for your button and make that a high signal. You know what I'm saying?
Yeah.
A little bit longer, even a
Okay.
little bit longer, just to be safe.
Yeah.
Basically, that ensures the minimum amount of hold time in order for the bouncer to like recognize. That should be good. Now, even, yeah, just make that high and just run that and you'll see that you're going to get a good output.
Okay. So can you explain that to me one more time, how that works?
Yeah, no worries. So that formula, so you see how
Beautiful.
it, boom, there it is.
Thank you.
So yeah, so that formula P period equals 2 raised to the number of bits over frequency.
Okay.
Basically is a formula for how long your switch period needs to be on, like how long your switch literally is on in order for it to go through that debouncer circuit and output a good result.
Okay.
Because remember, like if there's not enough hold time, it'll fail to recognize that the signal was over there and it won't output anything.
Which is why I had all zeros for mine.
Exactly. So you just weren't doing it long enough. And
Gotcha.
so
Gotcha.
now with 4 bits, because yeah, with 16 bits, you can imagine that number gets a lot bigger.
Right.
So that's why I had you bring it down to 4. So 2, you know, to the 4th is a little bit smaller than 2 to the 16th. And then divide that by the clock frequency, which, you know, here on Cordis in the waveform simulator, if it says every 10 nanoseconds, that means the actual period is 20 nanoseconds.
Mm.
So all you do is, you know, 1 divided by 20 nanoseconds, you get your frequency, which my calculator, I think that's, it's like 50 megahertz.
Okay.
And so, or not 50 megahertz, sorry, 0.5 megahertz. But anyways, yeah, if you just do that formula and then you'll get a time value. And so, yeah, when I did the math, I got that value 320 microseconds. So,
Awesome. Okay.
or not microseconds, sorry, nanoseconds.
Yeah.
And
Yeah.
yeah,
I'm
that's
with
why
you.
Obviously, it's a little bit different because I think I routed somewhere differently there, but you can see like after about 320, your result actually goes high. So if you do it again, like you see at like 800 nanoseconds,
Yeah.
if you hold it until like 1.12 microseconds, it'll do it again. And so
Okay.
you can just keep messing around with that.
Okay. Awesome.
But if theoretically that makes sense, then I'm stoked.
Yes, it does. Thank you.
Perfect. No worries.
How do you change the clock speed?
You want to show me your screen?
No, I want to just you to tell me. I don't want, it's nothing to do with the program. I don't want to count the length.
You just want to
He's-
extend, you just want to change your actual clock cycle?
Yeah, he says 19 bits gives 10.5 milliseconds with a 500 hertz clock. A
Yeah, so-
millihertz.
Yeah, the problem with like 19 bits and doing that on a clock is that it condenses it a lot and you're gonna have very, very small tick marks trying to fit in all those clock cycles
Right.
on the waveform simulator. So just for like experimental purposes, I would just change it down to like 8 and like see that it works. And then for functional purposes, yeah, then you can change your code back to 19 when you upload it to your FPGA.
Mhm.
But
Well,
I would change it to 8 so you can see it much better.
I did it down to 10, but
Okay.
yeah, 6 or 8 would be better. Yeah.
Mhm.
Okay. Thank you.
No worries. And if you need help changing the actual clock in the waveform editor, just let me know.
all move to part two. The up-down counter design with synchronous reset. I believe most of you have done it before. Here we need just to use the generic or 16-bit. Any problem with this part?
No, I think I have the right one.
Okay. Let's take another half an hour for this one, for those who didn't complete it.
Professor, is the class going until 9 or is it going later?
Pardon me?
Is the class going until 9 or until later?
No, regular class, 3 hours.
Oh, oh, okay, cool. Thank you.
Hello, Jim.
Hello, sir.
Are you ready to show part B?
I have the up and down yet, but I don't have the part where it's asserted either up or down. I just have it up or down. So I need to put a part in that says, if it's 1, you go up. If it's -1, you go down, and otherwise you hold still. But
Okay.
I'll show you what I have.
No, we can wait a few more minutes until you finish it.
There
Okay,
it is.
go ahead. Can you all see it?
Yes.
Mr. Ballard, I would recommend creating 2 separate inputs for the up and down then.
I will. That's what I was just working on now.
And I cannot see generic statement.
I haven't put that in either.
Okay, okay. Thank you. Chad,
Yes, Professor.
ready to show?
It's on my desktop. I can try to turn on my camera and show you.
Yes.
Okay.
You cannot log in using your desktop?
I can, but it doesn't have a mic or like a webcam or anything.
So we will not see you, but you can share the screen.
Right. Okay. Yeah. Let me try doing that.
Okay. Until he does, Jose, can you show us something?
I ran into an issue because I've been doing it with my phone. Well, I've been in this room through my phone. I'm pretty sure I forgot my charger at my house in Woodburn, the other house that I was staying at.
You are saying
So I
that
was-
your laptop is stolen?
No, the laptop died.
Okay, okay.
But I've been listening and seeing the slides through my phone. That's what I can do. So
Okay.
I'll just work on it whenever I can get my hands on the charger.
Paige, do you have it ready?
Yes, I do.
Okay, go ahead, please, until Chad gets ready.
Okay, so here is the code for it. And then I just closed out of the waveform, so give me a
Okay.
second. Actually, I'll probably make that bigger. Sorry, it's taking a second. Okay, so, there we go. There it is. And then you can see when the down is high, it goes back down from that. I think that should be how it works. Is that correct?
Would you please reduce the steps, the clock, the grid
Yes.
size, the grid size?
Yes, you can't really see the output because there's 16 bits. I could change it to a different one. I could,
Yeah.
yeah. Do you want me to change it in my
Yes,
code?
yes.
Okay.
No, I believe in your edit, in your waveform generator.
Oh, I
The
see.
grid
Okay.
size.
Okay, I will do that really quick. Where is that? Counter. Where did I have it saved? Okay, well, we're gonna redo that again.
Okay.
Oh, boy. Huh. You know why it's doing this? There's no,
List.
no,
Did you hit list?
yes, I thought so. Edit, insert, post, under list.
It is not related to the other program.
Okay.
Close everything. Do you have another one running with
Oh,
another
yes.
waveform
Oh my
generator?
goodness.
Okay, you
Thank
can
you.
you can change the other one.
Yes, that's my debounce. Too many things opening up right now. Up, down, again. Okay. There we go. How fast would you like the clock? Professor,
Yeah.
how fast did you want the clock?
No, just the. No, I'm saying the. Go to edit. Edit.
Edit.
We have grid size. This is the one that needs to be small.
Smaller or larger?
Yes, this one should be. I should see about 10 clocks. What is the frequency of the clock you have? What the time duration for
30.
each clock?
30 was mine.
30?
Oh, it'd be 60. Sorry.
Yeah. Okay.
So I'm just gonna go 60. There we go. And then, all right, we're gonna do this one more time.
Okay.
And up. Okay.
As you said, yes, you are correct. We cannot see it. Yes, it is. Yes, yes, it is here. Yeah. 1, 2, then it goes to 3 and 4, 5,
Paige,
Yes,
4.
click on your count arrow, please. Thank
yes.
you.
Yeah. Yeah, it is going up, down. Yes, it is working perfect. Thank you.
Awesome. Thank you.
You fixed yours, Jim?
No, I'm still working on. I was looking at pages.
Oh, okay.
Professor, I think I need some help. I'm getting an error that I can't fix.
Okay.
All right, I'm gonna share my screen.
Show it and everybody will help.
Okay, so right here, it's saying can't write to interface object count down.
No. You go from the line 1, explain what you have. And try
Okay.
to enlarge it, please. We cannot see it.
You can't see this whole screen?
Can you enlarge? Because it's very small letters. When you share it, it is very small on our side.
Maybe because of the screen scaling. 1 sec, let me stop and then I'll do it again.
Okay.
Okay, can you guys see this?
Yeah, better.
Oh, okay. So you have 16-bit up-down counter, declared the libraries. This is my entity. I created the generic size, 16 bits.
Yeah.
Here are my ports, the clock, reset, and I called it count up, and then count down is 2 separate inputs. And then count output is what we have here, 16 bits, 15 down to 0. And then the architecture is declared as behavior. Signal of the counter, obviously standard logic vector because there's 16 bits. And the process includes the clock, reset, and then the up and down counting. So once the rising clock is high, because it's synchronous, then if the reset is 1, then the counter will go to 0. However, if rising edge is still high and the count up is 1, then just to ensure that you can't have both the up and down be 1 at the same time, I said count down is 0. And additionally, the counter will add 1, obviously, since we're counting up. Else if the count down is 1, vice versa, the count up has to be 0, so you can't have both.
No, this is
contradicting
a mistake. This is a mistake. Count down is an input. How can you make it an output?
Oh, I see. Okay, so I don't need this.
Yes, you don't need it. This is one thing. And if you insist on using it, you can use another signal. But here, you declared it as input.
I see. So here,
Delete it.
Count?
Delete it.
This also
Yeah.
can be deleted. Oh, okay. Okay. In
Do
that
you
case,
have another similar thing?
that was the only instance where that was the case, because if count
Yeah.
up is 1, then I wanted to say count down is 0, but no. Okay, so if count up is 1, then the counter is going to add 1, and then else if the count down is 1, then the counter is obviously going to go down 1, and then for all their instances, it just should stay the same, and then end the process. So let me run that now. That makes a lot more sense. Oh, there we go. Thank you, Professor.
You are welcome. I cannot see the generic here.
The generic is right here,
Where?
up here. Can you see the highlighted?
Oh, yes. Thank you.
All right, no problem. Want me to make a waveform?
Show us the running waveform.
Oh, okay, let's do this. Okay, so we have a clock reset. I'm gonna make the count the output. I'll switch these two. Okay. Let's see, let's just make the clock. Let's hit a reset to begin with. I'm just going to try this out. So I have a reset to start, and then I'm going to count up for a long time, count down for a little bit, and then count back up again. That should be good. A little difficult to see.
Okay, working fine.
Awesome. Thank you.
Thank you all. Would you please stop sharing?
Yes.
Was that Vitaly?
Yep, that was me.
I didn't understand something about your program.
Which part?
Well, go up to part 2.
Share Vitaly for the last time.
I think the instruction said if they're both set up and down, it's not supposed to do anything. And it looked to me like maybe I missed something, but yours was either going to go up or it was going to go down.
That's what I was wondering too, but I wasn't quite sure with the logic of it, if that was correct or not, so I didn't really comment on it.
See, if your count up was 1, it was going to count up. If your count down was 1, I think it was going to count down. But what if count up was 1 and count down was 1?
Oh, I missed that part in the directions. I see. So, and remain unchanged if either input is in the same state.
I think somehow you have to do that, yeah.
Yeah, I did embedded if statements, so if up was 1, then I went to the next one and
Would you
said,
share your page? Share your
Yeah, share
screen?
yours, Paige, please.
Okay. Oh. That is not it. Oh, actually it is. I just did, so if there's a clock, then if up was 1, then I went to the next one to register the down value. And if it was 0, then I did Q plus 1 as my counter, and then else just Q equaled Q. I know I probably could leave that out, but it just helps me follow with it. And then that like registers every time the combinations of U, and then I went to U as 0 and then did the same thing. But it could be wrong, so let me know if, actually, never mind, we checked it.
It is working.
It is working.
So you see how yours says else Q equals Q?
Yeah,
Yeah, so I have that same statement, and that ensures that if they're both the same state, basically anything else where if up and down are both 0 or up and down are both 1, the counter's just gonna remain the same. My
Right.
definitive statements just say if only one of them has to be up, then it's either gonna, sorry, if up is 1, then it's gonna count up, and if down is 1, it's gonna count down. But everything
Right,
else should stay the same. So I think that statement itself like clears
okay.
that.
Because if we're doing our most efficient code there, though, we should be able to not have this little statement, though, right? I just don't know how to do the most efficient code.
I see what I did wrong was I just wrote, you know how you have else if U equals 0, then if D equals 1. I just wrote, without the if, D has to equal 1 as if it was an output. So that's where I
Oh,
messed
I
up.
see.
I guess mine would have worked if I just wrote it as an if statement because it was still counted as an input.
Right.
But ultimately we have the same thing, just minus that one part.
Okay, perfect.
But thank you for the critique, Dr. Ballard.
Welcome.
All right, am I good? Stop sharing.
Any more comments? Any more comments? Thank you.
Yep.
As you can see, we are sharing ideas and we are helping each other. This is the best way for learning.
Can we share ideas on part 3? Because I am not understanding how to get that to work with one another.
Let's see first what is part 3. Part 3 now, I am combining part 1 and 2. In part 2, we had some switches. Those switches, we are going to use real switches. We are going to use real switches from our kit. We are going to use real switches from our kit, and using those real switches from our kit, I need the bouncing switch. So to debounce it, I'm using the same counter I had before, but I need for it to use our kit. We have many buttons we can use. We have many switches we can use. We can use them for whatever. We have them for reset. We can use them for up or down. So we have those, and whatever you use, you are going to use part 1 to implement a debouncer for it. I will stop sharing and wait for your comments, or you can work on it, whatever you like. If Paige wants to share something, you are welcome.
Professor, if I understand this correctly, do we have to create a component in the debouncing code and then create a port map for the up-down counter that we did?
Yes, yes. What we did, we need to repeat it, just combine the two.
Oh, okay, thank you.
The up and down will not be from your waveform generator. It will come from your system, from your switch. The switch on the board. How many LEDs do you have on the board?
10,
How
I
many?
think, right?
How many LEDs, how many LEDs do you have on the board?
We have 10.
10?
Yes.
Okay, we can forget about the waveform generator and work with the LED. As you are pushing up, the LED will be giving us our binary code. But we cannot work on 16-bit. We can work 8 bits, that's enough. And since you are having generic, you have one line to change. And instead of 16, you put 8. And you are using the 8 LEDs to show the counter as it's going up or down.
Aren't we using 4 bits or is that,
Hmm?
it says set the counter generic parameter size to 4 bits? Or are we just doing it for 8? Just,
No, you can use it for 8 because so I can see it on the LED. The LED, you have only 10.
okay,
We are limited by the number of LEDs.
gotcha, okay.
Okay.
So, Professor, I have a question. When,
Go ahead.
so actually, can I share my screen?
Okay.
Okay. So I am looking at this. And I know the like directions say to instantiate 3 copies of the switch to bouncer. So when I do that, is it like doing this where I call it like 3 times in the counter?
No, you call it whenever you are using one of the inputs. The debouncer is for the switch.
For the up down counter.
We have go up,
Up.
you have reset. Is this input or not?
Yes.
It will be one of the switches on the board.
Yes.
So this will go to a debouncer. Up, it is another input. It will go to a debouncer.
Okay. I guess I don't know
If-
how. I don't know how to show that in the code. How like the reset goes to the bouncer, up goes to the bouncer.
How
Down.
did you do it in the program 2? In the first program?
In the first program, like the counter or the debounce.
The debounce. What was the input here?
The clock and the button.
The button was the input that you had it to start the first D flip-flop.
Right. Okay, so then different question then. I guess I don't understand how they're interacting with one another. Would you be able to explain that?
Go back to the first one. This, the button input. Where does it come from?
The user?
No. This comes from the user. Can you change it and make it to come from one of your input, your switches on the board?
Yes, I can make it correspond with that.
Okay, that is how we are gonna do it. That is how we are gonna do it. We are gonna use one of the switches up. So I will have debounce this program, and I will have another one and a third one.
Okay.
So we
So,
can,
right,
one solution
just-
is to use it as a component and put this as a part on your main folder and call it 3 times.
Okay,
Call it
so then
whenever
how
you
does
are
it,
using up or down or reset.
wait, can you repeat that one more time? What about the up, down and reset? Cause I'm not understanding how the counter and the debounce are interacting with one another. Like, why do I need to call the debounce within the up, down counter?
Because I need a switch for the up-down counter. Have you made this up-down counter with the switches?
May I say something?
Okay,
So if you hit switch 1, that makes, suppose you hit switch 1 or button 1, excuse me, and that makes you start counting up.
Okay,
When you hit that button, you need to debounce the button to make sure that you really have a 1. In other words, every time a button is pushed on the machine, it needs to be debounced before it really reads the signal.
okay, gotcha.
So if you hit a 1, it automatically goes to debounce. If you hit the first button, 0, let's say, or whatever it's called, it automatically goes to debounce returns the signal. You hit
Gotcha.
the second button, the same thing happens.
Okay,
That was confusing to me too, how to make them go back and forth.
right. And so then whenever there's an input on this counter, basically, I
Right,
have to go to the debounce.
exactly.
And so that goes for not the clock, but reset, up, down.
yes, 3 only. Reset, up and down.
Okay, I got you. Thank you.
Thank you.
So Professor, I'm still kind of working through the logic of the when one of the things change in the up down counter, how it worked with the debounce. But basically, when I change something in the counter, it will take, I go to the debounce and it will, whatever's being changed, it'll hold the value of button basically.
Which counter? The counter in the debounce or the main counter?
The main counter. So
The
say
main counter doesn't see the debounce. It takes the output of the debounce only as a switch.
oh yes, I know that. Sorry, I just meant the whole program.
Okay.
I was just referring to the program. So here, I'm gonna share my screen. I don't know if it'll help, but it may help me. Okay, so if say this up changes, I'm gonna go to debounce, and debounce is gonna take the value of up and it's gonna hold it in button. And it's gonna go through using that value up that's stored in button, and then it's gonna, like, the output is gonna be the result, and the result's gonna catch it and store it back in this one. Is that correct?
Mm. So here it is called reset. Or
Yes,
the up.
or yeah, reset up or down, right? Those are the things that are gonna be changing for the most part. And those are the
Yeah.
things that are gonna get debounced.
Yes, so the reset, for example, will go to the debounce and come back as a result.
Right, and so it's gonna, so transferring from this program to debounce,
And
the
come back.
value of reset is gonna be held in this value.
Yeah, the value coming from the switch itself will go here
Right.
into the bottom. Yeah.
Yes, so say this is high, say up is high, then it's gonna go to debounce, button is gonna be stored as high. It's gonna go through with all these like logic statements, and then it's
Mm.
gonna come back as result
Yeah.
into here.
Now we need to see how do you, this is the port.
Right, so then so this is the port of the counter, but my port that's calling the debounce. So I called it debounce low, just because it's not a high VHD else project. It's gonna come in here, so the result, and then do I hold the result with a signal? Should I be creating a signal for the result?
Yeah, the result should go to a signal. Yes.
Okay. So signal, debouncer, results. And then that's gonna be. Okay. So. Okay. Thank you. I'll probably ask you another question if I think of
Okay.
one in the next 5 minutes.
I believe we are out of time now.
Okay,
So I will let you work in it and think about it more. And please observe the deadline of those assignments, because the coming Monday, we are going to start a new topic. Whether you finished or not, we are going to start the memory. And it's going to take the whole week before we go into our final week. Okay? I wish you a great break and enjoy the break. Thank you all.
Thank you.
Bye-bye.
Thank you
Thank you,
for everything,
Professor. Have a
Professor.
great
Thank you.
Thanksgiving.
Thank you. Bye-bye.
Have a great Thanksgiving.
Have a great day. Enjoy yourself.
Thank you.